In this video, we're still going to be looking at the coordinate plane, but now instead of just looking at points on the coordinate plane, we want to take a look at lines, and we want to learn more about the slope of those lines and what exactly does slope mean. So say we have this red line that I graphed on this coordinate plane. The slope is telling us how high we go, or how high we go every time that we are going over 1 unit. So when I go over 1 unit, how far up or down am I going? As I go 1 unit to the right, how far up or down do I go? So with this red line, we have a pretty moderate slope. We can see that if I graph another line like this blue line, it's going to have an even greater slope than the red line. This green line is going down. This green line is actually going to have a negative slope. And then if I graph one more line, I'll graph this orange line here. This orange line has an even more negative slope. And well, where does slope appear? Okay, well, the equation for a line we're going to have is y equals mx plus b. Okay, this is going to say some y value, right, for any coordinate that falls on this line. We could say this is some coordinate x comma y. Okay, it has that y value. It must satisfy this relationship where m refers to the slope and b refers to the y-intercept. Okay, the y-intercept. I kind of ran out of room there. All right, and that's just any xy point will make this a true statement. Any point x comma y that falls on that line makes this a true statement, but we need to know our slope and the y-intercept. Well, for today's lesson, we're really covering this slope, which is represented by the letter m in our equation for a line. So we already talked a little bit about this, but a positive slope means as we go to the right, we go up. Okay, so as I go to the right, my line is going up. This here is a positive slope. Whereas with negative, as we go to the right, we are decreasing. So we're going down. Okay, as we go to the right, we decrease there. When our slope is 0, as we go to the right, we don't go up or down at all. We remain totally flat. It's just a flat, constant line. And then undefined, well, undefined, we can't be going left to the right. It's actually just a straight up and down line. And we'll see why we call that an undefined slope soon. All right, so these are the different types of slopes that we can have: positive, negative, 0, or undefined. So finding slope. How do we find the slope? I already said it's for every 1 we go in the right direction, it tells us how far up or down we're going. So if my slope is 3, that tells me when I go over 1, I'm going up 3. Okay, we are going to say that our slope, our m, is going to be equal to the rise of the line over the run of the line. Okay, rise over run is something that you will hear very frequently. So the rise just means the change in the y values, right? The y values are the ones that go up and down. And the run is the change in the x values. When I draw this triangle here, that just means the change, okay? So it's my change in y over my change in x. In other words, it is my rise over my run. So let's take a look at these examples over here. I can see going from one point on the line to another point on the line, I have to go over 1, 2, 3, 4. So I'm going over 4 and I'm going up 3. Okay, I'm going up 3, I'm going to the right 4. So that tells me that my slope of the red line, well, the rise is up 3, the run is right 4. So my slope is 3/4 for that red line. For the blue line, I start at this point here and I end at this point here. Well, I'm going to the right 2, so I'll call that a positive 2. And then I'm going down 4 units. I'm going down 4 units. So I will mark that off as a negative. Okay, for this line, my slope is going to be a negative 4 over 2, which of course we want to simplify. That is a slope of negative 2. Okay, my slope is a negative 2, and I can see, well, it is going down. As I go to the right, it goes down, so it makes sense that I'm going to be negative here. All right, so let's say that we are just given 2 points on a graph, and how can we find the slope between those 2 points? So I'll write those 2 points. I am just going to say, well, we have some point that we'll call P1, and the coordinates of that point are just going to be x1, comma, y1. All right, again, those are just variables, guys. It represents some number, okay? We don't know what they are in this case. We want to do the general equation for slope. So this is my point 1, x1, comma, y1. And then let's use this point here. We'll call this point 2. And of course, that's x2, comma, y2. All right, so we have these 2 points. And I know that my line goes through these 2 points. I know that's not a straight line, guys. I'm doing my best here. All right, well, we want to figure out, well, what's our rise and what's our run? How could we kind of solve this? Well, as I go, let's use a different color. Let's use blue here to show. As I go to the right, that's my run. That's my run distance. And then from here down, that's going to be my rise distance. So this here is my rise, and actually I'll do that in red. Let's do rise in red. And in blue, this here is my run. All right, well, what is the rise? How can I find the rise using this? Well, we talked about on the last slide that the rise is just going to be our change in y values. So I'm going from y1 to y2. Well, how do I find that difference? Remember that difference refers to subtraction. So we say that rise is my change in y, and that is going to be y2 minus y1. That tells me how far I changed in the y direction because we need to find the difference between the two y values. For run, well, we know run is the change in x, and obviously that's just going to be the difference in our two x values. So we look at x2 minus x1. So my rise is y2 minus y1. My run is x2 minus x1. Let's put this all together and find what is the slope. Well, I know slope is rise over run. And that tells me it's my change in y over the change in x, which is, let's just plug in, well, I know change in y is y2 minus y1 over x2 minus x1. So that's what we're going to use to find the slope of a line when we have 2 points on that line. All right, so make sure that you have that copied down. Let's do a quick example with this. All right, we'll clear all of our drawings. So find the slope. Find the slope of the line that passes through, and then I'll give you 2 points. That passes through let's go with -3, -6, and 4, -1. All right, well, I know that my slope is equal to my rise over my run, my change in y over my change in x, or y2 minus y1 over x2 minus x1. Now, the thing here, guys, is it doesn't matter if we accidentally mix up, like, oh, which one of these is P1 and which one of these is P2. It doesn't actually matter as long as we stay consistent. And what I mean by that is if we start by subtracting y2 minus y1, we have to also start with x2 in the denominator. Okay, so that the 2's must line up. These 1's must line up. Okay, you cannot do, and I'll write this in red, you cannot do y2 minus y1 over x1 minus x2. That is not okay. All right, that is not okay. However, what we could do is we could switch it and do y1 minus y2 over x1 minus x2. All right, either way that we do it, we're going to get the same exact answer, because by switching both, we would just make them both the negative of the original, and we know a negative divided by a negative is a positive, so it would be the exact same. So let's just continue on with this problem here. My y2 is this -1. So -1 minus a -6. I know that just means plus 6. So -1 plus 6. And then x2 is 4 minus a -3, which is plus 3. And I would get 5 over 7. So the slope of this line is going to be 5/7. And finally, let's just find slope given an equation of the line. Well, I know that our general equation of a line is y equals mx plus b, where this m is going to represent our slope. So in this first problem, problem A, we have y equals -3/2 times x plus 6. Well, my slope is clearly just that -3/2. For B, in this case, I don't have an x, right? I don't have something multiplying times the x. Well, I could even think of rewriting this as y equals, well, there's no x, right? What is no? It's 0. There's 0x plus 4. So in this case, my slope is going to be 0. Hope that this helped you guys out, and good luck working with slope.